in order to get the sum to product formulas, I'm going to make a substitution to rearrange the product to sum formulas to give me the sum to product formulas. I think I said that right. It's a little bit confusing. But that's what I'm going to do. So what I'm going to do is take this first sum to product formula and turn it into a product to sum. And I'm going to do that by, well, first what I'm going to do is just multiply this 2 over here. And I'm going to do that for all of these, but I'm just going to start with this one. So in order to get the product to sum formulas, I'm going to need to eliminate these terms. Well, I need to eliminate one of each, so I have a cosine alpha and a cosine beta, as opposed to a cosine alpha minus beta and a cosine alpha plus beta. So what I'm going to do is make this substitution. Alpha is equal to alpha plus beta over 2. Beta is equal to alpha minus beta over 2. And the over 2 will make some more sense once I make this substitution. Essentially what I need to do is, like as I explained earlier, is eliminate either from this term either the alpha or the beta, and for this term either the alpha or the beta. So when I make this substitution, it's going to eliminate one of those two terms, leaving me with 2 of the remaining term. So that's why I want to substitute in the over 2 part, if that makes any sense right now. But it will make very much sense shortly. So if I go ahead and make these substitutions, I'm going to substitute in alpha plus beta over 2, and then beta is alpha minus beta over 2. And same for this one. So if I just look at this right hand side of the formula right now, and then this first cosine, I can see that the alphas are going to eliminate each other. That's why the over 2 was necessary. If this over 2 wasn't here, I'd be left with, well, minus beta, so 2 beta. When I have the over 2, I have half a beta here and half a beta over here, and it will equal 1 beta in the end. So the alphas will eliminate each other for this term, and for this cosine over here, the betas are going to eliminate each other, leaving the alphas. So this sum to product formula will look like this. Cosine, I'm just going to put the right hand side on this side. So that's the way formulas are usually written, but it doesn't really matter. So for this one, alphas are going to be eliminated. Minus beta, positive beta, cosine beta minus cosine, and here the alphas or the betas eliminate each other, leaving the alphas remaining. Quite often this formula is written with a minus sign over here, and they just switch the alpha and the beta. So if I multiply both sides by minus 1, I'll get cosine alpha. It just makes the alpha positive. I guess it's just more aesthetically pleasing to people who write math books. So this would be minus 2 sine alpha plus beta over 2 so here is a sum to product. I have a difference of cosines and they equal some product of sines. So that's one of them. And it's the same process for the rest of these. I guess I might as well just do it since I'm already over here. But it's a pretty dull affair. It's not very interesting, but I guess I'll do this one next. What's the difference between these formulas? Cosine, whatever, it's plus sine instead. So I'm going to go ahead for this second one and just multiply the 2 to both sides and just eliminate this half thing. No sense in wasting a whole line on that. Actually, I'm thinking of the wrong formula. I'll do it in this color. So this one is going to be cosine. Difference was it was a plus instead. So plus cosine alpha plus beta. Let me double check before I waste a bunch of my own time. So yeah, multiply that. Cosine alpha minus beta plus cosine alpha plus beta. Yeah, I wrote it right. And this is the same thing. To make this substitution, alpha is equal to alpha plus beta. Beta is equal to alpha minus beta. Same sort of thing is going to happen. Oh yeah, over 2. I forgot. So for this cosine, the alphas will be eliminated. For this cosine, the basic betas will be eliminated. So this will leave cosine. Well, we'll just do it in order. Cosine alpha plus cosine beta. So that's another one. For cosines, this one's the difference, this one was the sum. Now I'll use the third one to get the sine. Sine alpha cosine beta 1/2 sine alpha plus beta sine alpha minus beta. I'll just go ahead and put the 2 over here and just eliminate the 1/2. That was plus, right? Yeah. Same procedure as last time. very simple. These formulas are really useless. But it is useful when learning trigonometry to go ahead and do them just to learn how to manipulate trigonometric formulas. But they have little practical use. Betas are eliminated here, alphas are eliminated over here. So this is sine alpha, sine beta. This is for sine, at least the sum of sine. Now for the difference of sine, might be a little bit tricky, I guess, for some people, but it's not really. It just seems that I've run out of formulas, but what I'm going to do is use the same formula. This one, obviously I can't use these ones because they're cosine. Well, I could change it, I guess, substitute sines in for cosines, but I don't really need to do that. I can just use this same formula, and in order to get the difference of sines, just make a substitution and use the even-odd properties of sine in order to change one of these signs from a positive to a negative. So if I have the same formula that I started with last time, let's go ahead and start with this one right here. I'll do this. So I have 2 sine alpha cosine beta. Now the object here is going to be to get to get one of each sign to have just an alpha or a beta. So to get an alpha and a beta eliminated from these, but also to have the sign reversed of one of these, sine alpha plus beta or sine alpha minus beta, I need to get the sign to change for one of them, so it's a difference of signs. And I can do that by making a different substitution. What the hell was that? So I can't do alpha plus beta alpha minus beta, or I can't, well I can, but I can't do the same order. So this is what I mean. I can't just substitute in alpha is equal to alpha minus beta, or alpha plus beta. But what I can do though is just reverse these. I can do, that's a really bad beta. Beta is equal to alpha plus beta over 2, and alpha is equal to alpha minus beta over 2. And I did that just by going back to my formula and just thinking about it. I just went over here because alpha minus beta, this addition, it's not going to matter what alpha or beta is, because it's because it's going to be an addition, it's going to be the same for whatever order these two terms are in. But for this subtraction, it does make a difference which order the terms are in. So instead of getting a negative beta, like a negative beta canceling each other out in order to become a positive beta, I'm going to get a negative beta that time, which is what I want, because sine of a negative angle is equal to just minus sine of that angle. So if I make the substitution, oh, I almost made a dumb mistake. So I've just reversed the values for alpha and beta, is what I've done. That's all. I just thought about it, and I just thought that if I reverse the order of alpha plus beta for these two terms, it's not going to make a difference for this sign, but it will make a difference for the second sign, and therefore it's going to change the sign of that, just that one sign. I don't want to change the sign for both of them, just for one. So this will be alpha minus beta 2 plus alpha plus beta over 2. And then here's where the difference is going to be made, because this is going to be alpha minus beta over 2, and now it's going to be minus alpha plus beta over 2. And previously these were reversed, and this beta was a minus beta, so minus beta was a positive beta, so it didn't change the sign of this term. But now, since the alphas are still going to be eliminated, but I'm going to be left with a minus beta, and then I'm going to use the even odd properties of this and say that this is just, instead of plus sign, just minus. This will be just minus sine beta instead of sine of minus beta, which is the same thing. So that's how they get this formula. Well, they get both formulas from the single formula just by reversing the order of the substitution, just due to the fact that this is an addition and this is a subtraction. So it won't make a difference for this addition. It doesn't matter what order I add two things, but if I change, but for subtraction it does make a difference. So this is just going to be sine for here, beta is eliminated, sine alpha, and now minus sine beta. Or I could just do plus sine minus beta, but whatever, it's the same thing. So that was a very long, tedious, boring video. There they are. This is the sum to product for a sine. Both of these, this is the sum to product for